Welcome to Homework Lib.
Hi, so in this case we're dealing with the equilibrium of silver oxalate Ag2C2O4 as a solid that is going to go into solution as two equivalents of silver plus one equivalent of C2O4 2 minus. Okay? We know that in this solution the concentration of silver plus that we find at saturation is equal to 2.3 times 10 to the minus 4 molar. So now, in order to know the value for KSP, what we need to do is we start with our ice table of the solid, it doesn't matter, and we start with 0 and 0 of each of the ions. The amount that is going to dissolve is minus S, the molar solubility, and in this case we're going to produce plus 2S and S. That means that at equilibrium, the solid, it doesn't matter, but we're going to have 2S and S. Now, the definition for KSP for this system is going to be equal to the concentration of silver plus squared times the concentration of C2O4 2 minus directly. If we replace this with the values that we find at equilibrium, this is going to be equal to 2S squared times S. That is going to give us 4S cubed. So, in order to know the value for KSP, we simply need to know the value for S. We are provided the value for the concentration of Ag plus, that is 2.3 times 10 to the minus 4 molar. This is equal to 2S, thus S will be equal to 1.15 times 10 to the minus 4 molar. We simply divide that quantity by 2, right? So, in order to know the KSP, we now only need to apply our equation. We elevate this quantity to the cube and multiply it by 4. And we get the value for KSP for this system is going to be 6.0835 times 10 to the minus 12. Remember that equilibrium constants never use units because we are, in theory, employing the activities of the components that we have. And that will be all. Thank you very much.